Hello friends. So as part of the big data introduction, in this playlist we will talk about current scenario of enterprise applications, and then we will see the challenges and how they can be addressed using big data ecosystem. After talking about big data and all, so the current scenario, if you think about any enterprise, all the applications can be categorized into operational and decision support. When we say operational, some of the operational applications are transactional and some might not be transactional. So all the core business applications can be considered as operational, and also there are some complementary applications which are operational but not transactional. But all the core business applications are operational and transactional. And then the example for operationally is for a retail store, a point of sale system where you check out your groceries in a retail store, and the point of sale system is operational. And then there are other kind of applications called decision support systems. And one of the example for decision support is if you want to see the trend of sales of a particular product in all the stores for a retail customer, then it is decision support. So as name suggests, by leveraging those applications, you can come up with sound decisions for your business. So it is primarily used for forecasting and all, but in short, all the enterprise applications can be categorized into operational and decision support. And this is the typical architecture nowadays, whether it is operational or decision support system. They follow entire architecture. You will have a database server, and then you will have a cluster of application servers, and UI will be on your browser. Whether it is a core application or decision support, a tool that will be used for decision support, this is the architecture we follow. For example, again, if you go for point of sale system, a client can need not be a browser, but all the client requests go through app server or web servers, and then the data will be loaded into database. And also, if you think about the email, your email servers, they also follow the same architecture. Even for decision support systems, we use tools like Cognos, Informatica, or any other BI or ETL tool, and most of them fall under this category. So if you take, for example, if you take Cognos, all the development will be done using your browser, and then there will be web servers or application servers in the middle, and then repositories will be stored in the database. Even if you take Informatica, which is a ETL tool, it follows the same architecture. Your Informatica metadata will be stored in the database, and then there will be Informatica servers, and then you use a client to actually build the mappings for your ETL. So, in short, what I'm trying to say here is, irrespective of the application, irrespective of the category of your enterprise application, they follow this entire architecture where you have cluster of databases, cluster of application servers, and clients. Depending upon the type of the client might change. It can be a browser, it can be anything, but everyone follows the same architecture. And if you follow the IT trends recently, most of the core business applications are already built around 5 to 6 years back, and most of the core applications are in maintenance mode, to add more features and all those things, but nothing started from scratch. Okay. And the recent trends of those core business applications means sorry recent trends in the enterprises, they are focusing primarily on standardization and consolidation of hardware. So for example, servers, storage and network, they want to standardize so that they can cut down the maintenance costs. And also storage is physically separated from servers and connected with high speed fiber optics. The reason why they want to separate storage from servers is that there is a lot of innovation happened in storage layer, where you can mirror storage or hard disks, and also um, to make the hard disks more fault tolerant, they introduce a concept called RAID. There are multiple levels of RAID. Because of all these concepts, they felt it to be feasible to separate storage from the servers, so that they can give more advanced features like fault tolerance, file abstraction, and all those things. So in short, the recent trends are to consolidate the hardware and also physically separate storage from the servers. And this is how it will look like. So you have a storage cluster. I am talking about a typical database architecture in an enterprise. You have a storage cluster. All these blue boxes, you can visualize them as hard disks. So there are a bunch of hard disks in a storage cluster, and then you can actually create pools of out of this storage, and you can mount that pool of storage as a to your database servers. And this storage cluster will be connected with the database servers using network switch, and also there will be another network switch just for communication between the database servers. So this is how a recent clustered databases are built. You will have a series of database servers which will be connected using a private network, and also these database servers will be connected with storage cluster, and where you will have bunch of hard disks, out of which you will create a pool for your pool of storage that is required for your database, and that pool of storage will be mounted as mounted through network on all the database servers. And the advantages of the current database architecture is they are clustered. You can think of Oracle RAC, high availability. So in the previous picture, if one of the database server is down, still the applications can be supported by the other database servers, because all of them will have access to the same storage. So they are highly available. One database server doesn't mean that applications are completely down. And then fault tolerance. So fault tolerance is yeah, even if you if one of the hard disk fails, still still there is no issue with the cluster. You can because at the storage level, you can configure a concept called RAID, where you can have multiple copies of the same data, and depending upon the RAID level, it can support the fault tolerance of hard disks. Also, if even if motherboard dies on a given database server, and even if you have to remove one of the database servers out of the cluster, still you should be able to support the applications. And then load balancing. So as you have multiple database servers, you can consolidate multiple applications to one database, and using the service layer in Oracle, you can create different levels of load balancing across the database servers. So for example, if your application points to this database server, sorry, to this cluster, in application server layer, there is something called connection pool, and you can define number of connections in your connection pool, and there is a service in between the application server and the database servers. That service can translate can talk to all the database servers. So when you define a connection pool of say 300, and if you have 3 database servers, and if your service can work with all the 3 database servers, 100 connections will go to one database server, and the other 100 connections will go to another database server, and the other connection will go to 100 database server. So all the 300 connections are distributed across all the database servers in the cluster. So that is what load balancing is. And scalable. So one thing you need to keep in mind is, even though clustered databases are scalable, it is not linear. I will come back to this in a moment. So now what I'm trying to say is, let's say a single database server can support 1,000 connections or 1,000 users at any given point in time. um, uh, and if it reaches threshold, you can add more database servers, and it can definitely support more than 1,000 users, as you have more database servers now. One can support 1,000, and if you add more database servers, these more, for example, two more, these 3 database servers can definitely support more than 1,000 users in the clustered environment, and that is called scalable. And why I am saying it is not linear is, let me draw whiteboard here. So when it comes to databases, and when you set up using clusters, uh, it will not scale linearly. I will talk about why it cannot scale linearly. For now, I will just explain why what is not linear. Okay, so if you draw a graph, and here if you put number of database servers 1, 2, 3, 4, and here if you put the users 1,000, 2,000, 3,000, 4,000. So for example, if one database server can support 1,000 users, 2 database servers will not be able to support 2,000 users due to the challenges that are involved with um, with the due to the overhead a clustered databases bring onto the table. So two server database cluster might be able to support 1,500 users, and 3 server database might be able to support only 2,000 users, and 4 server database server might be able to support only 2,300 users, and then it might not even scale up, it might scale down. So if you draw the curve, this is not linear. If it is linear, a linear curve should look like this. One database server will support 1,000, 2 database servers should support 2,000, 3 database servers should support 3,000, and 4 database servers should support 4,000. So it will be a straight line. Okay, so this is how a linear curve will look like. But in this case, as Oracle RAC database or any other traditional RDBMS RAC clustered databases will not scale linearly. The curve might look like this. And then as we have common network storage, we can leverage the concepts of file abstraction and fault tolerance. So if you go back to the picture, now if you think about it, each hard disk might be 500 GB capacity, and if you have 100 hard disks like that, that means you can actually support 50 terabytes of storage. So you have 50 terabytes of storage in this storage server or storage cluster. Now you can create a logical file system which is called as a pool, storage pool, of the size you need for your database. For example, if your database requires 5 terabytes of storage, you can carve out 5 terabytes of storage out of the storage cluster, and then your file can be of any size up to that 5 terabytes. So to start with, I have mentioned that each hard disk is 500 GB, and if it is if you want to create a file, you cannot create a file larger than 500 GB. The largest file can be only 500 GB. But as we are using a storage cluster of 100 such hard disks, 500 GB hard 100 hard disks of 500 GB, and you can carve out the storage of whatever size you want up to 100 terabyte. Now your file size can be much larger than your hard disk size. That is called as file abstraction. And then fault tolerance, which I have explained earlier. Even if one of the hard disks is pulled out for maintenance, still there should not be any downtime for your applications because of the concept called RAID. There will be multiple copies of the same data in your storage cluster, and it will facilitate the fault tolerance of your storage. Okay, so almost all these applications follow similar NTR architecture, whether it is core applications or enterprise integration applications, CRM, ERP, DW or BI tools. All of these use the same architecture in the enterprises. However, there are exceptions. For example, mainframes which uses closed architecture might not fit into the architecture which I have explained earlier. Okay, this is the bird's eye view of an enterprise. You have the storage servers, and then you have very thick database servers, and these tend to be very powerful compared to the application servers. That's why I put a wide rectangle here, and then you can have application servers like this. And in the next video, I will cover challenges about the current scenario, and then we will see how big data can solve a few of these issues as part of the ecosystem. I hope you will you enjoy this video, and also I hope you will enjoy the rest of the series. Thank you. Bye.